Hi and welcome to this OCR Paper 1 Maths GCSE Foundation Tier Prediction. Enjoy! Hi, welcome to this prediction from On Maths. Now, with this prediction, what we've done is we've looked at all the previous exam paper questions, seen what comes up regularly, what's long overdue to come up, and we've created this predicted paper. Now, this predicted paper you can also do online if you click up here, and it's completely for free, and you can even sign up to save your scores. Now, the online version will change the numbers each time you do it, so you'll get a unique experience. You won't just remember answers, but the methods you'll see in this video, you'll use exactly the same. We've also got topic busters on the site, which are just focused on a specific topic, and we've got them for all the Maths GCSE topics. We've also got videos on this site for every single type of exam paper question. And also we've got the revisionator on our site, which is for short, quick revision. So if you've got 10, 15 minutes and you want just a completely random selection of questions, then please go and check that out on our site. Now, as we always say with these videos, please do not fully rely on this as your only revision strategy. Please do this alongside all your other revision for these reset papers. If you've enjoyed this video, please click like. And if you want to see more from us, especially Paper 2 and Paper 3 coming up very, very soon, please click subscribe. Enjoy. So for this question, you just kind of got to imagine what the shape will look like when it's finished. And the thing that's stopping it from looking perfect is not having this square here. And let's just check it has 4 lines of symmetry when I put that in. So we've got one there, we've got one across here, then we have a diagonal one here, and then we've got another diagonal one here. So it has 4 lines of symmetry. For this question, we need to understand the difference between multiples and factors. Multiples are just a numbers times table. So the multiples of 5 will be 5, 10, 15, 20, etc, etc. Now every number in the 5 times table ends in 0 or 5. So looking at the list of numbers we've got here, there's only one that ends in a 5 or a 0, which is 10. So 10 is a multiple of 5. Now factors go the other way. A factor of a number means that the number, so 24, is in another numbers times table. So 24, and the easiest way to find the factors of 24 is you start off with 1 and 24, because 1 times 24 is 24. Then you go 2 times, 12, 3 times 8, 4 times, and you think how many 4s? 6. 5 times, well that doesn't work. 6 times we've already got. So those 8 numbers are the factors of 24. Then I look at the list, well, already there's a 24 there. Is there any other ones I could have written? I don't see any other ones, so 24 is my answer there. 2 prime numbers. Now prime numbers mean they only have 2 factors, 1 and themselves. Okay, that's a prime number. If there's any more factors, it's not a prime number. So let's go through the list. 10 is in the 5 times table, which we identified in question A, so that's not a prime number. 24, well, we've listed out 6 other factors of 24, so that's not in it. 18 is 3 times 6, so that's not going to be it. 17, I don't think of any times tables that 17 is in, so I'm going to say 17 is a prime number, which it is. And 19, well, I can't think of any times tables 19 is in, so I think that's a prime number. Let's go through the rest to make sure. So 16 is 2 and 8, so that's not a prime number. And any even number apart from 2 is not going to be a prime number. 2 is the only even prime number. 27 looks like it might be, but actually 3 times 9 is 27, so it's definitely not. And 28 is another even number. So it looks like we found the 2 prime numbers. So this question is asking us to convert worded numbers into just numbers. So it says 2,605. So when we're thinking about numbers, we think about what column each of the digits are in. So we have our units column here, We have our tens column here, we have our hundreds here, and we have our thousands here. So we have 2,000, so I can put a 2 in here, 600. Now, it doesn't say any tens. If it said 35, I could put a 3 in the tens column, but there's no tens in that number, so I'm just going to put a 0, and 5. Now, when you look at that number, you think, oh, that's 2,605, and that's what it says in the question. So that's our answer. Okay, for this question, we've got a ruler next to a line, and all we need to do is read off how long the line is, and it says the ruler is showing centimetres. Now, a really common mistake with this is to write down 4.1. If I zoom in on that little bit there, at the end of the line, you can see that there are 4 little notches there. Now, the most important thing we work out with this question is what are each of those notches worth? So it's going to be 4.0 here and 5.0 here. Well, it's going to be, if we try 0.1, so we can try 4.1, 4.2, 4.3, 4.4, 4.5, so it's not going to work. So it's going to be 4.2, 4.4, 4.6, 4.8 and 5. So therefore they're going up in 0.2s, not 0.1s. So the answer is going to be 4.2, not 4.1. So in this question we're given a train timetable, and we've got 4 towns. We've got Ashcook, Flute, Risetown and Colib. And the bus is obviously starting at Ashcook and then finishing at Colib, passing through these towns as it goes. So it says that we arrive at 2017 at Ashcook. Now we will have missed this train and we'll have missed this train, but we'll be in time for this train, so we'll take the 2032 train. Now that will stop at Flute at 2052, but we're looking to see how quick we can get to Risetown, which is the next stop there. We'll get to Risetown 21:24. So we're given function machines for this question, and it says what is the output when the input's 24. So the input's 24, and the first thing that's going to happen to it is it's going to divide by 2, so we're going to halve it. So that's going to make it 12. Then it says we're going to add 6. So when we add 6 to 12, we get 18. So the output is 18. Next question says below is a different number machine. It says when the input is 20, the output is 56. So let's follow through on the input. So the input's 20, we go take away 6, so that's going to give us 14. Now we've got to then think, right, how do I get from 14 to 56? Now, as it stands, there are multiple ways of doing this. If you do this on onmaths.com, it has a drop-down box and it only lets you select one of the options. So you can add a number to 14 to get to 56, and for this question that would be full marks, that would be absolutely fine. Or you can times it by 4, and times by 4 is the one I'm going to go for. So I'm going to complete the number machine by saying times 4. So this question asks us to write the smallest odd number. Now there's 2 instructions there. We need to make the smallest number from the digits, and it needs to be odd. So to make the smallest number, we want to use the smallest digits on the left hand side of the number and the largest digits on the right hand side of the number. Okay. We also need the last number to be odd. Now to make a number odd, the last number needs to be 1, 3, 5, 7 or 9. Okay, so looking at the largest numbers, the largest number is 6, so we want to end on a 6. However, 6 is an even number, therefore if we end on a 6, it will be an even number. So we've got to look at the largest odd number, which is the 5. So the 5 is going to go here to make the number odd. Then we need to use up that 6 next. and then the next largest number is the 4, and then 3. So my answer is 3,465. Now always just check to see whether we've answered the question. It says it wants the smallest odd number. Well, that's an odd number, and I can't think of a way of swapping those digits to make it any smaller, because we've used the smallest numbers we can on the left hand side and the biggest on the right hand side. Okay, so we're asked for all the possible combinations of sweets. The important thing here is to be methodical whenever you are asked a question like this. So I'm going to start with the first one and pair it up with the second one. And I'm going to keep with the first one, which is apple, and pair it up with the third one. And then I can't do any more with apple because I've got both the combinations down. So I'm going to move on to the second one, which is banana, and pair it up with coconut. And those are the 3 options. So with these types of questions, just make sure you have a nice routine, and you'll normally have items that have a different first letter, so it's just a bit easier to write them down. Rather than writing apple, I just write A, and that's absolutely fine. With any sequence, the first thing to check is whether it goes up by the same amount. Well, looking at this goes up by 1, this goes up by 3, so it's not going up by the same amount. This goes up by 4, this goes up by 7. But something you might notice is this goes up by 7, and yet there's a 7 here. This one goes up by 4, and there's a 4 here. This goes up by 3, and there's a 3 here. This is what we call the Fibonacci sequence. So the Fibonacci sequence just starts off with 2 numbers, and then we add the previous 2 terms to get to the next term. So we'll add these 2 together to get to the next one. Then we add these 2 together to get to the next one. So to find the next one, we need to add the 11 and the 18 together. 18 plus 11 is going to be 29. So the next term is going to be the 29th term. Let's just check that's the 6th term. 1, 2, 3, 4, 5. So yes, that would be the 6th term, would be 29. Then we need to add the 18 and the 29 together. And when the numbers get big, if it's not on the calculator paper, you can just add them like this. So 9 plus 8 is 17, and that's going to be 3 plus 1, which is 4. So it's going to be 47. So the 7th term is going to be 47. So always just check that the sequence isn't a Fibonacci sequence before you start to panic and think, what is this sequence? Always check for a Fibonacci sequence. It was just that the previous 2 terms are added together to make the next term. Okay, so for this question we're asked to construct a pie chart from the table. We've got a number of frequencies. Now the first thing to do is work out how many frequencies we've got in total. So first calculation I'll make is adding up all the frequencies, and that calculator tells me is 24. Okay, now the problem we have is a circle has to add up to 360, and at the moment all of our frequencies add up to 24, so we've got to find out what we're going to multiply all these frequencies by to get them to add up to 360. We do that really simply by doing the calculation 360 divided by whatever the total of the frequencies are. So 360 divided by 24 on the calculator equals 15. So this 15 here, if we multiply all 3 of our numbers by 15, we will get the amount of degrees we need each colour to be. So I'm going to add an extra column here and say angle, and I'm going to do 14 times 15, and it's 210 degrees. 7 times 15 is 105 degrees, and 3 times 15 is 45 degrees. And let's just check this. Let's add them up. 210 plus 105 plus 45 equals 360. and then you need to plot it onto the pie chart. Now, I don't have a protractor on this, so I can't physically do it, and to be honest, it's much more helpful to physically print this out, do it on a piece of paper, and get someone to help you use the protractor if you're not 100% sure. That 210, for instance, what I would do is probably draw a straight line down here, like a mini sort of working out line, and do 210 take away 180, which is 30, and do sort of 30 extra degrees, which is going to roughly be there. And don't forget to label them, so that would be red. 105 is just over 90, and I'm just doing this roughly. I'm not even going to use a straight line to show that it's not accurate, and then label that blue, and then check that you've got 45 left over, and hopefully you do, and then label that other. Okay, so this is quite a tricky question. So we've got a set of axes and we're given a line on it, and we're asked to find the equation of the line. So let's have a look at this line. At every point on this line, okay, even points between the lines, at every single point, x is continually changing. If we have a look at the x values, they continually change. So x is a variable, x will just keep changing. But if you have a look at the y is always 3, anywhere on that line. So the equation of the line is y equals 3, because y is always 3 anywhere on that line. So horizontal lines are always going to be y equals something, and vertical lines are always going to be x equals something. Make sure that you know the names of the parts of the circles. So a diameter is a line that just goes across a circle going through the centre. If it doesn't go through the centre but it goes across the circle, it's a chord. A bit of a circumference is the whole way around the circle. A bit of a circumference is called an arc. And there's a few more parts of a circle you need to know. Now, on this question, there's a line which touches the circle just at one point, and it's a straight line. The name for that is tangent. This question is just asking you to work out 13% of 2,680, then work out 8% of 3,114, and then write down which is the biggest, okay, which person gave the most. So first of all, we want to do 13% of 2,680, and since it's a calculator paper, then we can do that by just converting the percentage into a fraction. So percent means over 100, and timesing it by the amount. So on my calculator, I will do 13 over 100 and times that by 2,680. And it might give you a fraction, just press the S to D button, and that gives me 348.4, and in money that's 40, because obviously we do 2 decimal places for money. And I haven't shown the examiner who that is, so I'm just going to show the examiner that that's James we're working out. So on to Paul next. So we want 8% of 3,114. So we're going to do 8 over 100 times 3114. So fraction button, 8 over 100. Or we could do 8 divided by 100. Gives you the same answer, 3114. And that's going to be £249.12. So obviously James gave the most because that's the biggest number. So my answer will be James. And it says who gives the most to charity and by how much. So we need to work out by how much. So 348.40 take away 249.12. So 348.4 take away 249.12, and that gets me 99.28. So it's £99.28. So to find a coordinate, it's really simple. There's only one mistake really that people make. the first thing to do is find out what the x coordinate is. So the x coordinate is 2. And so the first coordinate is 2. Then find out what the y coordinate is. So the y coordinate is -3. Now some people think of this as starting in the middle and going along the corridor to the 2 and then down the stairs, or up the stairs. This one it's down the stairs to -3. Now it's really common for students to get these muddled up, so just remember we always do the x, so the horizontal, we go across first and then the y, which means we go up or down. Okay, so the numbers in this question seem a bit daunting, but the process is always the same with this type of question in ratios. The first thing you've got to realise is, are you given a total amount or are you given an amount of food or amount of drink? Where it says in total they spend that amount, so it's a total amount. So step 1 is to work out how many parts you have altogether. So for food it's 39 and for drink it's 4. And this will be a calculator question, so why not use the calculator even though we can do it in our head. 43 parts. So we've got 43 parts. The next stage of this is to work out what one part is worth. So one part is worth how much? Well, you get the amount and you divide it by the number of parts. You're splitting the amount of money between 43 parts. So 11911 divided by 43. And I get £277. So each one part is worth £277. Now let's read the question. Find how much money is spent on drink. Well, drink is this one here. And the order which they are in the question, food, drink, is the order which the ratios are. So food, then drink here. So there are 4 parts. So we're just going to write drink. So if each one part's worth 277, we're just going to do 4 lots of that. And I might as well do it on the calculator, times by 4, and that's going to be 1108, so 1108. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up, but I'm going to do this in pence. So I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now, some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down over how much you've gone right. So that's going to be 10. Now, it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile. And I'm going to put in brackets 10p. Now, it could be that just writing the cost per mile for this question would give you the mark. But if you actually wrote the gradient as well, then you definitely get the mark. And sometimes it will ask you for the gradient and then ask you to interpret it. With best value questions, which this is one of, there's normally multiple ways of doing it. Either you get the price per item, or you get how much of the item you get for 1 pence, or you get them to so that they're the same amount of items and then you compare the prices. Now this one asks for the price per tissue, so that's the way we've got to answer this question. So we're going to have tissues on the left hand side and price, and I'm going to do it in pence because it's normally a lot easier to work out when it's in pence. I'm just going to draw a line down the side. So we're going to start off with the box of 24, and it costs 802 pence. Now to get one tissue, I'm going to divide both sides by 24. So if I divide both sides by 24, I get one tissue. So I do 802 divided by 24, and I get 33.416 recurring. Okay, let's try the next one. So that's one done. In fact, if I draw a line, then I can show that I've done that. Okay, so the next one is 20 tissues, and that costs 689 pence. So this time I'm going to divide both sides by 20, so I know how much one tissue costs. So 689 divided by 20 on the calculator, and I get 34.45 pence. Okay, and the last one, let's draw our line. So the last one's 15 tissues, and it costs 538 pence. So this time I'm going to divide both sides by 15 to work out one tissue. Okay, so 538 divided by 15, and this time I get 35.86 recurring. Okay, so first of all, let's get the price in. So it says rounded to 2 decimal places. Okay, so this first one is 33.42, because that one moves up. The 20 tissue box is 34.45, and the last one is 35.87, because that 6 would round up. So which one is the best value? Well, if you have a look at the 24 tissue box, it's only costing 33 pence, just over 33 pence, whilst the 20 tissue box costs over 34 pence, and the 15 tissue box costs over 35 pence. Well, which one would you rather buy? Well, I'd rather buy the one that the tissues cost the least. So the best value is the 24 soft tissues. Now, in your answer, make sure that you write exactly the same as in the question, so that it's absolutely clear which one that you think is the best value. Now, if you worked the other way, if the question didn't specify how to do it, and you were working out the amount of tissues you get per penny, then obviously it works the other way. You want the biggest number, because you want the maximum amount of tissues per penny. So just be a little bit careful of that. Okay, for this question we're asked to find the cost of the toffees and the fudges. Now, if we imagine that we had 2 toffees and 3 fudges, how would you work this out? Well, the cost would be 2 times 50p, and then we would add 3 times 70p. The problem is that 2 and 3 I've just made up, so that's not going to be the answer to this question. What it says though is that it wants toffees to be called T, and fudges, the amount of fudges, to be called F. So instead of 2 toffees, we have T toffees. And instead of 3 fudges, we have F fudges. And in algebra, we always put the number before the letter, and we don't show the time sign. So it's 50T plus 70F. Now be careful, it does want the cost in pence, but sometimes it wants it in pounds. So if it wants it in pounds, it'd be 0.5t plus 0.7f. So the answer is C equals 50t plus 70f. And that can be either way around. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. Okay, so the first thing to do with this question is realise that x is sandwiched between -12 and -5. And all we need to do now is figure out what the sign's going to be. So x is going to be greater than -12, but it's also going to be equal to -12 because this dot here is filled in. X is smaller than -5, but it can't equal -5 because this dot here is hollow. Instead of going straight to percentages for this question, I would first of all get it as a fraction. So it says there's 15 students who are female and 31 altogether. So the fraction is going to be 15 over 31. And to simply convert between fractions and percentages, all you need to do is times by 100. And percent means per 100, so it's always going to be times by 100, and that'll always get you a percentage. So I'm going to get my calculator out. Now I can write that as a fraction, or I could do 15 divided by 31. It gives you the same answer. So 15 over 31 times by 100. And it gives me a fraction, so I'm going to press S to D. And it's 48.3870, blah, blah, blah. And it says give it to the nearest percent. So that's a 3, so it's not going to move that 8 up to a 9. So it's just 48%. Okay, so this question's about exchange rates, and this part here is quite important. If I just rewrite that to make it a bit bigger, this is basically saying that to get from pounds to dollars, we just need to times by 1.42. And you can get that by just dividing the right hand side by the left hand side. Now 1.42 divided by 1 is just 1.42. So the problem with this question though is that it wants the answer in pounds, so we'll need to convert both of these things into pounds. So we're actually going the other way. When we go the other way, instead of times, we just divide. So we're dividing both sides, or we're dividing dollars by 1.42 to get to pounds. So we've got $3,000, and we want to convert it into pounds. So we're going to divide it by 1.42, and I'm just going to type that into my calculator. So 3,000 divided by 1.42, and it's to the nearest pound 2112.6, and we'll round to 8. Obviously to 2 decimal places, because money is always to 2 decimal places. So it says also that that the laptop costs £2,500 in the UK, and how much cheaper is the laptop in the USA than the UK. So what we need to do now is we need to do £2,500, which is the price of the laptop in the UK. We're going to take away the £1,112.68. And on my calculator, I'm just going to type in 2,500 take away answer, and then press equals, and it gives me the answer of 387.32. So it's £387.32 cheaper. Okay, so this question asks us to find all possible integer values. Now it's really important we understand that integer just means whole number, or whole numbers, I should say. Integer is just a whole number, so we're looking for all the whole numbers that are between -2 and 4, and that's all this is saying, that x is anywhere between -2 and 4. But because this doesn't have a line underneath it, it does not include that number, so it doesn't include -2. This one, however, does have a line underneath it, so it does include 4. So the first one's going to be -1, 0, 1, 2, 3, and we include the 4, but we don't include the -2. So this is our answer. This question doesn't ask you to show the reasons for your working out, however most of the questions will, so let's try and make sure we write down some reasons as we go. The first one I'd go for is this one here, which I'm going to call A. Now I know that A is 180 take away 115, so 180 take away 100 is 80, take away 15 is 65 degrees, and the reason is it's angles on straight line. And if I know A, I know that B as well, so B is going to equal 65 degrees as well, because it's an isosceles triangle. All the bottom angles in an isosceles triangle equal, assuming that the isosceles triangle has the two same sides on the left and right. Obviously if it's rotated it's not the bottom two angles, but it's always going to be these two angles here. Okay, so B is 65. Now I can go straight to X, because these are parallel lines. X and B create a Z angle, and we need to figure out what the z angle is called, but we're going to say x is 65, it's the same as b. Now corresponding is the f one, interior or co-interior or allied angles are the c ones, so the one we've got left is alternate. They're alternate angles, they're z angles. So the answer I can write is 65 degrees. Okay, so whenever we're asked to estimate with a scatter graph, we're always going to start off by drawing a line of best fit. So I'm going to draw my line of best fit, and yours might be different to mine, and that's absolutely fine. Now, it's asking us to estimate the height, and it's giving us the width. And that's really important because the width is up the side. So a common mistake would be to read 17 from the bottom, but the height is at the bottom. So we've got to check the scale first, and it seems like it's going up in 2s. So let's just check that. Yep, it's going up in 2s. So what I want to do is draw a line across at the width of 17, which will be roughly here. I'm going to stop when it hits the line of best fit, and I'm going to draw a line down. And I'm going to read off what that is. Well, this scale is also going up in 2s, I think. Yep, it is. So the estimate of the height would be 4 centimeters. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food, and so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now because we used Denver's amount or fraction of the food to work out Engels and Fido's combined. So that's how much food they'll get. But they're sharing it in the ratio of 5 to 2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part is going to be worth, well, as a fraction, it's 16/19 divided by 7. So 16/19 on the calculator divided by 7, which gives us 16/133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32/133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction. And it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. So inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half because that's not a whole number. Now, x says here x is greater than -7 and is less than or equal to 3. So when it asks you to write down all the numbers that's true for, well, let's have a think. Well, if it's if it's greater than -7, then it can't be -7. It can't be equal to it. So it's going to be -6, -5, -4, -3, -2, -1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the -7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times -5 is -25. Now you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this -25. And you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that -25. So we're left with 15x on this side. And 35 plus 25 will be, well, 5 plus 35 is 40, 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20. So that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70. And then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So it's 900. That's 21 with a 0. So 900 plus 21, 210 even, 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 is 27, take away 1 is 26, take away 10 is £25.90. Now that's for 1 child, so that's 1 child. So if I want 2 children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit, and let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. In this question, we're asked to draw the line y equals 2x plus 3. Now, there's no x squared or x cubed, so I know it's going to be a straight line graph. Now, there's multiple ways of doing this. I'm going to do it using a table, and then I'm going to show you a few other tricks of doing it much quicker or checking that you've got it right. The first number I'm going to start with is 0, and this, what I'm circling now, is going to be a coordinate to plot on our graph. So the top number, the 0, is the x, so this is when x equals 0. And what I'm going to do is I'm going to feed that into my equation. So when x equals 0, or y equals 2 times x, so 2 times 0 plus 3. 2 times 0 is just 0. So y equals 3. Now you don't need to do this working out for every single number, but I'm just doing it to show you how I'm getting to the y. So I'm going to try the next one without any working out. So we've got 1, and so 2 times 1 is 2, plus 3 is 5. Then the next coordinate, we've got x equals 2, so 2 times 2 is 4, plus 3 is 7. And the next one, we've got 3. So 2 times 3 is 6, plus 3 is 9. Okay, and I always go back to the negatives because I can kind of see a pattern with the positive numbers. So I can use that pattern to check that I'm doing this right. So 2 times minus 1, well, positive times a negative is a negative, so that's minus 2. And minus 2 plus 3, well, if I just use the number line, minus 2 plus 3, so 1, 2, 3 will be 1. And I can notice that they're going down in 2, so 9, 7, 5, 3, 1. So let's try the next one. 2 times negative 2 is minus 4, minus 4 plus 3 is minus 1. Minus 3 times 2 is minus 6, minus 6 plus 3 is minus 3. So those are my final 2 coordinates. The next step is to plot the coordinates on the graph. So my first coordinate is minus 3, minus 3. My next one's minus 2, minus 1. Then we've got minus 1, 1. Then we've got 0, 3. Then we've got 1, 5. 2, 7. And 3, 9. Now I want to join those up with a straight line. So let's do that now. And the last step is to label it. And sometimes you're asked to draw more than one line. So we should label it. There we go. Now, I can check that this is right because all of the numbers landed on the straight line. If I had one coordinate down here, I'd always check it. You're never going to have a straight line graph that goes up and then dips down, then goes back up again. Okay, so it's an easy way to check that you've got it right. Now, I said there was a quicker way of doing this. If you have a look at the graph, the equation, y equals 2x plus 3. This plus 3 tells us where it's going to hit the y-axis. So I can plot that one straight away. This 2 is a gradient. So if I go across 1, it tells us how far up it's going to go. And I just do that a few times to get 3 coordinates. And I can draw my straight line graph from that, and I don't need to put the table. But if the question asks you to fill out the table, obviously you need to fill out the table. Okay, so the main problem with this question is that people don't know what a frequency polygon is. If you know what a frequency polygon is, I think most people will get this right. Frequency polygon is basically a line graph, but you plot these at the midpoints. So the first one's going to be plotted at 40. The next one, so if you don't know how to find a midpoint, you're just finding the halfway value between 0 and 80, which is 40. To do it a different way, you could add the two values together and halve it, and that works just as well. So 80 plus 160 is 240, and then halve it would be 120. 160 plus 240 is going to be 400, halve it is 200. Okay, so we're going to plot these at 40, 120 and 200. Now a different way of doing it is just plotting them halfway between the two lines. So we've got a line here and a line here, so we're just plotting them halfway. So it says frequency is 11, so looking at the scale it looks like it's going up in twos, so that would be 12, 14, 16, 18 and 20, so that works. So we're going to plot it halfway between the two red lines that I've just shown, and it's going to be halfway between 10 and 12, so it's going to be about here. And they're quite forgiving as long as they understand the point you're trying to do. If you're slightly off it, they are quite forgiving with that. Okay, so 120 is halfway between 80 and 160, and it's going to be 18 tall, which will be here. And 200 is going to be up to 6. So let's plot these 8, 6, 4, 2, and so 6 is going to be here. Now we haven't finished yet, we do need to join them up with straight lines. So let's just do that to finish off the question. And there we go, that is a frequency polygon. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got two decagons, and so that means they are 10-sided, and you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it, and then take that away from 360 to work out A, and that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Now a lot of people look at the word estimate and think, oh, let's just take a guess at it. The reason we're estimating is because of the first step that we have to do to answer this question. It doesn't mean that just have a quick punt and guess at it. With this question you won't be able to guess it correctly, or it'd be very, very unlikely. So we approach this the same as if it wasn't a group. However, we do have a group, so we've got to do a step first. This means that we've got a value somewhere between 0 and 4, including 4 but not including 0. Now the problem is that the first step in this method is to multiply these two numbers together, but you can't times somewhere between 0 and 4 by 14. So what we need to do first is find the midpoint. The reason we pick the midpoint is it's a good number to use to represent that group. If we assumed all those numbers were 0, then it would probably be ridiculously small. If we assumed they were all 4, again it would be too high. So we assume that all those are 2 because it's right in the middle of the group, and chances are that most of them are closer to 2 than 0 or 4. So we find the midpoint of each of the groups, and a way of doing this is just adding the lowest and highest value together and dividing it by 2. Or just having a look. 4 to 8 will be 6, 8 to 12 halfway would be 10, 12 to 16 halfway would be 14, and 16 to 20 halfway would be 18. Then what we do is we get the frequencies and times them by the midpoints. So it's the same as if it wasn't a group now. So we do 14 times 2, which is 28, 6 times 6 is 36, 3 times 10 is 30, and then you can use a calculator for this, so 9 times 14, have an idea of what it's going to be. Hopefully it's 126, which it is, good, and 2 times 18, which is 36. And this is I call this the fx, although in this case we are calling the first one s, so it's the fs column. And then we need to find the sum of the fs column. So we're going to add up 28, 36, 30, 126 and 36 on the calculator, which is 256. And then we're going to sum up the frequencies, which is this column here. So 14 plus 6 plus 3 plus 9 plus 2, which is 34. And then what we're going to do is we're going to get the 256, which is all our values added together, and divide it by 34. So 256 divided by 34. And I get the answer of 7.5294 blah blah blah. And to 2 decimal places, that's going to be 7.53. Now, the reason it's an estimate, as I've said before, is that we don't know that all the values in the first group are 2. We are estimating them to all be 2, even though we know that some of them will be 1, some of them will be 3. But chances are it will balance out that it's roughly going to be about 2 in that group, and 6 in the next group, and 10 in the group after. That's where the word estimate comes. The method for doing this is how I've shown it here. I don't believe there's any other methods you can use for this. So when you have a right angled triangle and you're given 2 of the lengths, and you're asked to find a third length, which I'm going to call x, then it's going to be Pythagoras. Be careful, because if there's an angle involved, either you're asked to find an angle or you're just given an angle on the side, then you'll be using trigonometry. So when we use Pythagoras, there are 2 methods that I know of to work it out. There's the algebraic method, which is a squared plus b squared equals c squared, and that's absolutely fine to use. I'm not going to use that method because if you're happy using that method, go on, use it, not a problem. The only thing to remember about that method is that c must be the hypotenuse. Okay, now I'm going to do a method that doesn't involve algebra at all for people who are not very happy with the a squared plus b squared equals c squared method. So my method comes with 3 steps. Step 1 is just square every number that you have and put the biggest one first. Okay, so I'm going to do 7.1 squared and I'm going to do 4.6 squared. So on my calculator, 7.1 squared, and that equals 50.41, and 4.6 squared equals 21.16. So step 1's done, I've squared them all. Step 2 is the only choice you have to make. You either have to add or subtract. Okay, now this is where we talk about the hypotenuse. The hypotenuse is the length that's opposite the right angle. So go to the right angle, go across from it, and that is the hypotenuse. So 7.1 is the hypotenuse. Now what's special about the hypotenuse and why it has a special name is it must be the longest side. So in step 2, have a think, well, if we add them, we'll get a bigger number. Well, the hypotenuse must be the biggest side. So when you're finding another side, not the hypotenuse, you will subtract. But if I was finding the hypotenuse, so I wanted a bigger number than the other two, then I would add. So I'm going to do 50.41 minus 21.16, and that's why in step 1 we did the biggest one first, because otherwise you'll get a negative number. So 50.41 take away 21.16, and that equals 29.25. Okay, and step 3 is a nice easy step. It's just root it. So with this one, I'm just going to press square root answer, and then I have, so I'm going to write that down, square root 29.25, and so that equals 5.4083, blah blah blah. It says it wants its 2 decimal places, so I'm going to write 5.41 because that 8 moves that 0 up by 1. Now, last step is just check it makes sense. Well, this being 5.41 means that the 7.1 is still the longest side, so we know we've probably got it right. Okay, to start off, when you're working out the nth term, you've got to work out what the sequence is going up in. Now this is a bit weird, this one, because it's going down, but we've still got to work out what it's going up in, so it goes up by -3 each time. And you always check that it continues, which it does. This number then goes before the letter n, so it's -3n. The next step is you go backwards 1 and find out what the 0th term is. So the 0th term here is going to be 20, because 20 take away 3 is 17. And this we add on to the end here. So it's -3n plus 20. And always check it. So for the first one, n is 1, so -3 times 1 is -3, plus 20 is 17. For the 5th term, -3 times 5 is -15, -15 plus 20 is 5, which is our 5th term. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got 2 sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SO, and it's not going to be KA, so it's going to be TOA. So TOA stands for tan x equals opposite over adjacent, and the opposite is 47, and the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens the set brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah blah blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on the calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here, and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, and we look at bag 2. Well, in bag 2 there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start, and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. And a blue from bag 2, well, that would stay the same, wouldn't it? Because there's still 4 blues and there's still 7 altogether. And there's 3 reds and 7 altogether. And that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red. So we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle 2 we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7, and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now, this is the problem, is we end up with 2 fractions. Well, we need one answer. So we need to find some way of combining those together. And in probability, we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now, the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. Okay, I understand the temptation in this question to say that the answer is 0. Please do not write that. Anything to the power of 0 is not 0. Anything to the power of 0 is 1. Now you can think about this. If you do x to the power of 5 divided by x to the power of 5, then the rule is that you take away the indices when you divide them. So it's x to the power of 0. And we know that any number divided by itself is always equal to 1. So the answer to this question is always going to be 1. Just try and remember that. Anything to the power of 0 is 1. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now, multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do. So either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always, and 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now, 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So on your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89, and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to the nearest penny because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to £917. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. Okay, so for this question we need to work out the length of the arc, which is around here, and then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator, and I'm going to add 37 and add another lot of 37. So add 37, add 37, and that gives me 168.2826 blah blah blah. Once it's 2 decimal places, so line goes down here and we've got 168.28. Now just be careful that you add on the extra bits. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Now I'm going to be using the multiplier method for this question. If you've got a different method that works really well, then stick with it. But you do need to know the multiplier method for the GCSE. Now the word that probably tricks most people is this one here. Depreciates means goes down. Okay, it means it loses value. So it goes down by 1.7% each year. So to work out the multiplier, you first of all start off with 100%. Now this time you take away 1.7%, okay, because it's going down by 1.7%. And you can do that on your calculator or in your head. So 100 take away 1.7 is 98.3%. Then you want to work it out as a multiplier. So you're going to do 98.3%. You just divide it by 100. And multiply is a posh way of saying decimal. So 0.983. Now, anytime I times something by 0.983, it will decrease it by 1.7%. So we've got a car we bought in 1980, and what is it worth in 1985? So that is 5 years. So it's going to depreciate by 1.7% every year. So we've got the 2,245. And if we times it by 0.983 once, that's 1 year. But we need to times it by that amount 5 times. And instead of writing that times 0.983 times 0.983 times 0.983 5 times, I can just do it to the power of 5. You get the same answer. So in the exam, you can just write times 0.983 5 times, and that's absolutely fine. You get the same answer. So 2245 on the calculator times 0.983 to the power of 5, and I get the answer of 2060.553687 blah blah blah. Okay, so because it's money, it's going to be 2 decimal places, so that's going to be 55. Now last thing is just to check your answer makes sense. Well, the car was worth 2,245. It has depreciated, but not by very much. 1.7% is not very much. So it's gone down, and it lost about, say, roughly £200. So the answer makes sense. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's to the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here.
I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.